I am Dr. Mohammad Rafi, Associate Professor, Department of Cybersecurity at Institute of Aeronautical Engineering. Today, I want to discuss about the boundary conditions. Here, the topics are server host crashes, server crashes, and rebooting, server shutting down. So, in this situation, what are the boundary the conditions? How can you recover the server crashes? Here, crashing of a server host. So this is the scenario. Now let us, what happen when the server host is crashes while the processing? What happened? To simulating now, we must run the client and a server on a different host. Server is one host, client will be run on another host. Different host we have to use for identifying or simulating the crashing of a server host. Then we starting the server, starting the client type, that means boundary. This server crashing server type is in line. Server crashing is in a line to the client. To verify that the connection is up or down, disconnect the server host from the networking and type in, that means crashing server, which type in another line at the client side. So this is also covers the scenario of the server host being unreachable when the client sends the data. That means here, if it is crashes means even though if the client sends the data, that data is unreachable to the server. Some immediate routers is down after the connection has been established. Here, while crashing this the server, now we'll consider when the server host the crashes, nothing is sent out in the existing network connection. If it is crashes, server is crashes, now we can't send from server to the remaining clients, and the server, if it is a fail, it can't receive the information from the clients. That is, now we are assuming that the host crashes, that is a server host crashes and is not shut down by the operator. Generally, this is the situation. And another thing now will take place. We type a line of input to the client, and it is written and is sent by the client TCP, Transmission Control Protocol, has a data segment. Then the client then blocks in the call to a read line waiting for the echoed replay. Same echoed replay means whatever the client sending, the server send back the same message to client. That is for the echoed replay. That is a read lining waiting for the echoed replay. If we watch the network with a TCP dump, we will generally see that the transmission control protocol which transmitting the data the segment from client to the server generally. So in this now, client sending the response. Once the server is received the response, that means the request, the server sending the acknowledgement along with the request. Server sending the response to client. Here is trying to receive the acknowledgement from the server. Generally, the client sending the request to the server. The server is sending the along with request acknowledgement also now the server sent to client. Berkeley derived some the implementations transmit the datagram or the segments which is 12 times waiting here while transmitting the data segment the 12 times as per the Berkeley derived the implementation. So that is a boundary the condition which implementation which satisfies the boundary condition which is transmitting the data segments 12 times which will be waiting around the 9 minutes before giving up. When the client finally give up, an error is returned to the client at the process. Whenever it is a crashes, so immediately sending the error or the message to client. Since the client is blocked in the call to read line, it returns an error message which assumes the server host which had crashed and there were no responses at the client data segment. That means finally here the error is e timed out. If the error is now which is sending e timed out, error message is timed out. Error message is timed out now, which is indicating the server is the crashes. If it is the server is the crashes, immediately e timed out the response sent to the client. If some of the intermediate the routers in between the client and the server, the intermediate the router now which determines that the server was unreachable whenever it is the crashes. Whenever the server is the crashing, so which is unreachable and responded with the ICMP the destination unreachable message. Message is unreachable. So that means here then error is either error host to unreach or error net unreach. Host unreach or net unreach. Net error net unreach. Error host unreach. This message the server send to the client. Generally these the information, the acknowledgement sent to the client, which detect that the server is unreachable even before 9 minutes. Place a timeout call to the read line. The lining should be the inline. Lining when it is when the crashes will happen here in inline only. Inline the server and clients are in a same line of the communication. So in these the load is the more load while the communicating server with the client here. So generally these the crashes or unreachable information will be happened before the here is the server is unreachable even before 9 minutes. So place the timeout. If it is a time is out, that means error message is sent. That is e host unreachable error message. Now whenever it is received, immediately the client will understood that the server is failed. Whenever this message error message is received by the server, and to finding the crash of servers, even if client is not sending the data actively. Here for that now we are using the one technique. So it is used. So keep alive socket option. Now by using keep alive socket option, now we are using this technique now to finding the crashes of the server if the client is not sending the data actively. Next, traditionally performance has been the most important metric when evaluating the system. However, in the last the decades, the industries and academia have been paying the increasing attention to another metric to evaluating the server's availability. A web server may serve many users when running, but if it is out of the service the too much time, so it becomes the useless and expensive. The industries and organizations has adapted the several techniques to improving the system availability. Yet crashes still happen. If the server crashes happened, so the industries and organizations should be so which adapt the several other techniques for improving the system, the availability and the performance and the scalability. Here, boundary the conditions of this server, the failure here, several fail in boundary conditions now. Generally, in a server, several other types of the failures will be they happened. That is top causes for why server fall. That is the causes is natural disaster. That means here the server disaster management it will be happened and a disk failure. If any disk is a failure, any hard disk is failure in a server, so these server failure will be happened. And if any virus or attacked, Trojan horse or any different the types of the viruses are available in the market. If any type of the virus is attacked here, generally the server will be crashed or failed the server. And failed, it is physical disaster, natural the disaster. Now with this one, the server will be failed. Overheating, if the server the performing the more number of the jobs, so then the capacity of the server, generally these overheating will be happen. Due to the overheating, server will be failed. Server will be failed. If it is a failed, the data, the signals cannot be reachable to the server. Data signals, it won't receive the signals from client and won't respond the signals to server. Hardware issues, any CPU problem or any RAM problems or any motherboard problems. So any hardware issues inside the server, so it is a causes for the failing, crashing of the server. Any software issues, any softwares are damaged, the expired, the software, whatever the softwares now we have installed in the server, if it is the expired, softwares are expired with this the software issue also, the server will be crashed and failed, the server will be failed. System overload. If you more data than the capacity of the server, if you load more other data, that means the system is overloaded, server will be failed. So, and cyber attacks. With the cyber attacks also, server will be failed. The cyber attackers now, they will attack the server and hacks the information and attacking. That means these the attacker introducing the viruses into this other server. Due to this virus attack and cyber attacks, the server will be failed. So these are all the server failure server failure tasks. Now the server, these are the top causes. These are all the causes for the server failure. And server as a failure, how to prevent the common server as a failures in a industry or any other organizations or any other institutions. So generally here is now ensure the optimal environment or the temperature. The temperature, this should be the optimal the temperature. Now we have to maintain the server room with minimum the temperature, optimum temperature. That means minimizing the temperature level in a server room and conducting the routine maintenance. Here is now we have to conduct the routine. The maintenance should be the, so every 1 week or every 2 weeks, every 3 weeks now, or every monthly wise. As per this now server smoothness for based on that now we have to we have to conduct the routine maintenance. Maintenance should be daily or weekly once or monthly once. We have to maintain the cleaning the server or the system. And here is the next regular install update. If is there any updates regularly, now we have to install the any updates in the server. And if you take the fourth the reason here in a server now, if you monitor the performance trends, if you regularly if you regularly monitoring the performance the trends, so now we can preventing the failures. Server failures can be prevented, and develops a server the continuous the plan. Server the continuous the plans you should have to develop, and designing the disasters and data recovery plans. Here, physical disaster, natural disaster. So you have to designing the causes, top the causes, physical disaster and natural the disaster. So avoiding that disaster, now we have to designing the for disaster the removal plan, and data recovery also. You have to design this. So with these by maintaining all these other things in a at server side here, now we can preventing the failures, common failure, whatever the common failures are happening at the server side here. Now we can controlling the, so these all the failures, and server failures. Enter here such the headlines here. Now server failure generally, if the server is failed, if the internal server is failed, immediately the host will get it as a that means won't the message is won't the whatever the information sent by the client. So this is the client and this one is a server. The sent message not received. If it is a fail, which indicate means the message is not reachable from the client, and so won't respond. This server is won't response. That means here, so this is a sample text that now you can edit, you can change the font, that means size, color, name. So here apply any desired other formatting, so that can be the applicable by the sample at the heading at the server side. At the client side, if you apply the sample at the heading, that means font size or editing, color, name, here it won't respond. When once the server is failed, so if you do anything, it won't respond. The server won't respond to your the actions, whatever the actions you are performing, and client other side, the server won't respond. These are the main server failing. Here is some of the examples of how socket programming can be used to creating the simple the charting. So here is the, for example, the Python, in Python programming, import the socket, now which is creating a socket object. So that is S is equals to socket dot socket family address family inet family, and socket streaming the family. So which is binding the socket to a port, particular port. So after creating a socket by using this code, so we can create the socket. After creating the socket, now we can bound with by using the bind the socket to a particular port. The port number is a 5000. Here is the port number is given as a 5000. That is s dot bind. So it will be the local host. And listen for the connections. S dot listen and accept the connection. That is connect address. So that is equals to s dot accepted. Once if it is accepted, now then only start the charting or communication server to the client or client to server. So here if it is failed, the server is failed, the acceptancy, the function which is won't work now, won't receive the responses from the client, and won't receive the responses from the server generally. So if it is a fail, we can't able to transmit the data. The server is a fail, we can't able to transmit the data from client to server. Here is generally for chatting, generally for the chatting from client to the server. Now which is receiving the data from the client, so that is data that is equals to connect receive 1024. From the port number 1024, data is equals to connect dot receive 1024. Now we can receive the data. Send data back to the client. That means connect dot send all hello world. This is a message sending the data back to the client. That is the same message, whatever the message received by the client, the server sending back the same message. That is, if it is sending the same message hello, it is a system is echoed system, closing the connection. Here, after completion of the transmission between the client and the server, generally finally we can close the other connection. That is a connect dot other close. By using this other function now we can close. Here is crashing and rebooting of a server host. Generally, so we will establish a connection between the client and the server, and then assume that the server host crashes, and once if it is the crashes, no, automatically it will be reboots. The easiest way to simulating these is to establish the connection and disconnect the server from the network other devices. Here, in crashing and rebooting, now shut down the server host and reboot it. After shutdowning, if you reboot now, again the server will be restart, and the reconnected the server host to the particular network, whatever the network now, over the network you are establishing we are performing the communication. So we have to reconnect the server host to the network. We don't want to the client to see the server host shutting down. Here is the client is not actively sending the data to the server. When the server host crashes, the client is not aware that the server host has crashed. Here is now, generally we can consider in this situation, generally we can consider it as we start the server and the client. We type a line to verify that the connection is established. The server host crashes and reboots. We type a line of the input to the client. Inline means here both server and client are they are establishing the communication inline. Here, which is set as a TCP data segment to the particular the expected server the system. Generally, these things will be considered. The host has crashed. And the fourth one is when the server host reboots after crashing, its TCP loses all information about the connections that exist before the crashes. That means here the server at the TCP now, which is a response to the received data segments from the client with an RST. Here is our client is blocked in the call to read lines when the RST received the signal. Whatever the received the signals now you are transmitting is received, causing read line to return the error connect reset. Here it is important for our the client to detecting the crashing of the server host. Very important now we can detect the crashes, the server the crashes. Even if the client is not actively sending the data, then some other other techniques such as so keep alive socket option or client the server heartbeat the function is required. Here is server shutting down. Server shutdown. So suppose here the properly you are not shut down the server. In this situation also sometimes no it will be failed. The crashes will be arise. That's why before leaving from the other system, so we have to properly shut down in the other system. So when a Unix system is shut down, the init the process normally sends the signal termination that is sig term signals to all the processors. This is the signal here sig the term now can be catched. Here it is waiting for some fixed amount of time, often between 5 and 20 seconds. In between these 20 seconds it will be waiting and then sends the signal kill signals. SIG kill signals which cannot catch us to any process still running, whatever the process now still running, which cannot be catch. So here these all now which is running the process a short amount of time to clean up and terminating the server. If you don't catch the any sig at the termination and terminate, our server will be terminated by sig the kill signals. When the process terminates, all the open descriptors are closed, and we then follow the same sequence of the steps. It will be discussed under the termination of the server process. Here, in this the termination, we have to select or poll the functions in the client, and to have the client detect the termination of the server or the process as soon as it occurs. If you see, server as a failure is a common issue. Server failure is a common issue, so that affects all organization types and sizes. Here, the cost of the server downtime can include days without the system access to loss of the critical the business data. This can lead to the operation issues, services, outages, and repairs cost. Here, one of the most the cause of the server crash is hardware malfunctioning. Is one of the most cause for system failure. Here, this can be include the physical damage, overhead, component failure, hardware issues can affect any part of the server, such as it may be the failed CPU, now RAM, disk, motherboard, or any network card. So it is generally these are all the hardware the functionings now. So these hardware issues can affecting the server failure at any cost of the region. And if you see a server, generally it happened. A server is a generally we can say it is a type of computer. It's run very fast. Suppose it runs fast, has a higher load and is more expensive than an ordinary computer. Here is a server is a one type of computer. It running very fast, has a higher load and is more expensive than an ordinary computers. If you compare the ordinary computers, the expensive also more and speed also very high than comparing with the ordinary computer in terms of the speed. Generally, these servers provides the computing and application services for other clients such as PCs, smartphones, ATM devices, and other terminals, even large equipment such as the train systems in the network connectivity. Here is the server has a high speed the CPU, central processing unit, now which is computing the power and long term reliable operations. So here is a powerful input output to the external data throughout and better scalability. Generally here, the server has the ability to respond to the service request and undertake the services and guarantee the services. As an electronic device, now the server has a very complicated internal structure, but it is not much difficult from the internal structures of an ordinary computer such as a CPU, hard disk, memory, system bus, etc. What happens if the server is the crashes? Once the server is the crashes while communicating the devices, generally there may be the problems with the various services which is built into the servers, and because the server serves the large number of people, the impact will be the wider and the consequences will be the more serious. Here is the server now which is impacted to the videos, finance, the gaming, and the data centers internally now which is impacted to data other centers. If anything, server is the failure here now which is impacted on videos, gaming, planning, and a data center. Whatever the data center you are using now, which is impacted. And you will see web video websites. Video websites means there is a large scale inaccessibility failure online video, so cannot be watching. That means here, in case the data in the server is lost and the original video and animations of any author can be restored, it will be the disaster. Financial system. A financial system with the tens of millions of the transactions per second, which requires a rock solid server. After all, here it has affected everyone, which the capital exchanges and the loss in calculable. Competitive games in online players of the popular competitive games may exceed the tens of millions of levels. Asking what is the experience of tens of millions of people being disconnected at the same time, there will be definitely not be a good answer. Here is what is the server is the crashing. Generally here, some of the reasons for crashing means a server cannot continue to provide the services. Generally, the one reason is a first contradiction between the fast growing number of users and the server's performance, which cannot grow at the same time. The impact of user growth on a server. Here is this is a user. Generally, the number of users are very less users. So now normally here now we can running the without failing, without affecting the data center. Now we can run the data at the center. If it is growing, that means the number of users are increases. That load will be more load on a server. So that's why the server will be, if it is a data is a more load, more data, now it will be the loaded. It is causes the failure or the crashes. The server here it may be the failure or the crash. And although the data center which containing the hundreds of servers, it can provide the services to the large number of users. When the number of users are grow too fast, the performance of the existing number of the servers will also reach the limit. If it is increasing the productivity, so will not happen overnight, resulting in productivity so falling short of the domestic demand. Building a brand new data center which requires a lot of time in a traditional method. We'll see next reason is a exhausting of the resources, that is CPU, memory or hard disk caused by the large number of service requests. Here is now, if you see the devices, number of devices, the requesting to the server. At the same time here, the number of devices, more number of devices are requested to the server will be failed. That means memory load data, CPU, the computing, hard disk drive, the capacity, it will be failed. When it is failing means here requesting more number of other devices are requesting to the server at a time for establishing the communication. So in this the situation, generally server will be failed. Here unexpected reasons. The unexpected reasons are, so while the clients are doing the job here, unexpected code and with hackers. These are all the unexpected. Hackers are unexpectedly attack the server and steal the information. So these are all the unexpected. And internal error. So any internal errors in the other servers. So next here is a break. Any cables are break. Cable breaks. Error code problem. All these are the problems now. Server will be failed. So these are all the problems of breaking the cable, hackers, and internal errors. Okay. So these are all the unexpected. Now will be all these are all the happen with the unexpected reason. And the references are These are all the references. Richard Stephen, Unix Network Programming, Volume 1, Pearson Education, third edition 2008. And Subramaniam, Network Management, the Principles and the Practices. So, Edison here, we'll see. So, Wesley, first the edition 2001. These are all the reference book. And web references. These three are the web references for boundary conditions.
Like, share and subscribe. Hit the bell icon for more updates.